Welcome to this video. In this video, we will look at what is Azure Service Bus Queue. Before going to start, we need a Azure subscription and a Visual Studio. Here, I am going to use Visual Studio 2022 with the latest update. We will cover what is Azure Service Bus. Then, we will create a queue and we will try to insert and remove the item from the queue using C# console application. First, we will look at what is Azure Service Bus. Azure Service Bus is a fully managed enterprise message broker service provided by Microsoft Azure. It is designed to facilitate communication between different applications and services that ensures messages are reliably transferred between sender and receiver. These are the key features of Azure Service Bus. Message queues. Queues allow messages to be sent and stored until the receiving application is ready to process them. This decouples the component of an application, improving the scalability and reliability. Messages in a queue are processed in a first in first out manner. Next one is topic and subscription. Topic allow messages to publish to the multiple subscriber. This is useful in a scenarios where a message need to be sent to multiple recipients. Each subscription to a topic can have a filter applied to it that allowing the subscriber to receive only the message that are relevant to them. Message sessions. Azure Service Bus supports message sessions which allows for the management of ordered message processing and correlation of messages in a session. This is particularly useful when the processing stateful workflows. Message routing. Service bus allows for the routing of a message based on content, enabling complex message processing pattern. This helps in a building distributed system that need to process message differently based on their content. Dead letter queues. Message that cannot be delivered or processed can be moved to a dead letter queue. This allows for the handling and analyzing of problematic message without disturbing the overall message flow. Some of the advanced features are transaction, duplicate detection, and scheduled messages. Transaction means ensure that a series of operations either all succeeded or failed together. Duplicate detection prevent the same message from being processed more than once. Scheduled messages allow for message to be scheduled for further delivery. These are the common use cases of Azure Service Bus. Decoupling applications. Service Bus can be used to decouple components of a distributed system, allowing them to operate independently. Load leveling. It can smooth out spike in a traffic by queuing up messages for processing at a steady rate. Reliable communication. Ensure messages are not lost, even if the receiving system is temporarily unavailable. Event distribution. Distribute events to multiple subscribers in a scalable way. Integration with Azure. Azure Service Bus integrate with all other Azure services like Azure Functions, Logic Apps, and Event Grids. It makes a powerful tool in a cloud-based, event-driven architecture. Overall, Azure Service Bus is a robust solution for building scalable, reliable, and decoupled distributed applications in the cloud. What is queue? A queue is a messaging entity that enables communication between different applications or services by allowing them to exchange message in a reliable and scalable way. It acts as a broker between sender and receiver. Some of the key features of a queue are NQ operation, DQ operation, first in first out. NQ operations means add an item at the end of the queue. DQ operation will do remove the first element in the list. First in, first out. The order in which elements are processed in the order in which they were added. We will try to create a service bus. Go to Azure Portal.
Under the integration category, you can see Azure Service Bus. Click on Service Bus. First, we need to create a namespace. What is namespace? A namespace is a container that provides a way to group and manage multiple messaging entities such as queues and topics. Logical grouping is the one of the main feature of namespace. A namespace allows you to group related messaging entity together. For example, you might have one namespace for all the messaging needs for a specific application or microservices. Each namespace is uniquely identified by a name within the Azure region where it is created. This name is used as part of the service bus endpoint URL, allowing applications to connect. The namespace provides a single point of management for security settings such as authentication and authorization. You can define shared access policy at the namespace level to control who can send or receive messages from the entities within that namespace. Namespace provide isolation, meaning that entities within one namespace cannot directly interact with the entities in other namespaces. This is useful for multi-tenant applications where different customers or environments require a separate namespace. Scalability and availability. A namespace can scale to handle a large volume of messages, and Azure ensure high availability and redundancy for messaging entities within the namespace. Monitoring and management. Azure Service Bus provides tool to monitor and manage the entities within a namespace.
We will try to create Azure Service Bus namespace. We need to select a resource group. I'm going to create a new resource group. Click on OK. Next, we need to provide namespace name. It should be unique name. Next, we need to select the location. By default, East Asia is selected. Keep it as it is. Next, we need to select pricing tier. Azure provides three types of pricing tiers: basic, standard, and premium. You can see the each pricing tier difference. In basic tier, you can see only the queue, but standard and premium tier, we can use both the queues and topics. We are going to select standard tier. Select, click on next, keep as it is, click on next, click on next. It's validating. Click on create. Now deployment is in progress. Deployment is completed. Click on go to resource. Now we have successfully created our service bus namespace. Next we need to create queue. On the left side you can see the entities. Click on entities. You can see both the queues and topics. Click on queues. Now we don't have any queues available in the list. So we need to create a new queue. Click on queue. Here we need to provide queue name. I am going to give elearn queue. You can see some other options as well like maximum queue size, maximum delay count, message time to leave and many settings. For time being keep it as it is and click on create. Now our first queue is created successfully. Click on queue name. This is our queue overview page. You can see the different sections here. Under the settings section, you can see maximum delivery count, current size, maximum size, message time to leave, auto delete, message lock duration, and free space. Below, you can see one more section, message count, active, scheduled, dead letter, transfer, and transfer dead letter. For time being, we don't have any message available inside the queue. Next, we will try to push one message to this queue. We will create a console application using Visual Studio 2022 and we will try to push one message to this queue. Go to Visual Studio. I have already created a solution. Inside the solution, we have two projects. One project is sender. This project is used for sending messages to queue. I have created one more project that for receiver. This project we are used for receiving messages from the queue. I have created this solution using .NET Framework 8. We need to install one NuGet package as well. Azure.messaging.service bus. I have already installed the same. First, we need to provide a connection string. This connection string we can get it from Azure Service Bus namespace. Go to Azure Portal. In the left side, you can see the settings menu. Click on Shared Access Policy. Click on Root to Manage Shared Access Key. Here you can see primary key, primary connection string, secondary connection string, and SAS policy ID. We need to select primary connection string. Copy, paste the value. We have two options to access queues. First one is SDK and another one is API. Here we are going to use SDK. So we already installed one NuGet package for this. First we need to create a client object, Service Bus Client. This class is coming from azure.message.servicebus NuGet package. Next we need to provide the queue name, elearn queue. So this is the name we are given inside Azure Portal. Next we need to create a sender. Var sender equal to client create sender then queue name. Next we need to create a service bus message. This message we are going to send to the queue. We will send the message asynchronously. Await sender dot send message async message. Finally, we will close the sender. Await sender dot close async. We will try to run the application. Now message is successfully sent. You can see the message done. We will check the message inside the queue. Go to Azure Portal. Under message count section, you can see one active message. Now our message insertion is successfully completed. Next we will try to retrieve the message from the queue. Go to Visual Studio. I have already created a project for retrieving message from the queue. Here also we need to create a client object. We need to copy the connection string. Then we need to create a receiver. We will create a variable receiver equal to client dot create receiver, then queue name. We will receive the message asynchronously. Var message equal to await receiver dot receive message async. If message is available, we will write message to console. Finally, we will complete the message. We will try to run the application. You can see the message is displaying on the console. We will check the queue as well. Go to Azure Portal. Now we don't have any active messages. In this video, we covered what is Azure Service Bus and what is queue. Also, we created a queue and we'll try to do the basic operation with the C# console application. I hope everyone understood this session. If you have any question, please put them in the comment section below. Thanks for watching.